Hello everyone, I am Ritik Roy and today I am going to solve my first assignment on maths of ordinary differential equation. So this is the sum. So first we need to find the if it is an exact differential equation or is it not an exact differential equation. For that we are going to use the formula m dx plus n dy equals to 0. So now we need to change it into that form. So now I have converted it into that form. Now I am going to take this equation m and this one as n. Now we need to do the partial differentiation of del m del y and del n del x by this equation. This is m and this is n. So after doing the partial differentiation, we can find that del m del y is equals to del n del x. So if both of the partial differentiation are equal, then we can say therefore it is exact. So it is an exact differential equation. So now we need to integrate this with this formula. Now here the m we need to keep the y constant, and here if there is an x term in here, the n has x terms in there, so we need to separate the x terms. We need to remove those terms which have x value. So let me solve here. So here I have integrated it. From m we are getting this value and from n we are getting this, as in every addition there is an x value. So we need to remove the part where there is x. So this is the answer. So the final answer is y sin x plus x sin y plus yx equals to c, which is constant. So this is how we have solved the first question. Now let's move to the second one. Now let's start the second sum. So again we need to check the exactness, and then if it is exact then we will integrate, and if it is not exact then we need to go to the 5 rules. So I was solving this differential equation and I have made some mistake later on, so I am omitting that part. So this equation is exact, so now we will solve the integrating part. Okay, so after solving the integrating value, we are getting e to the power xy plus y square equals to c, which is the answer of question number 2. So now let's move to question number 3. So it is again in the form which we needed, so we will put m and n. Now we will find the partial differential equation. So again both are equal, so it is an exact differential equation. Now again we need to integrate to find the answer. So after integrating we find out the answer x to the power 5 plus 3x 3 to the power x to the power 3 y to the power 2 minus x to the power 2 y to the power 3 minus y to the power 5 equals to c, which is constant. So this is the answer. So let's move to question number 4. So now we are moving to question number 4. So this is the last sum of the assignment we are doing right now. So to solve it, I can see that we need to first arrange it in the proper order. Now as I can see that this form is going to be linear differential equation. Now we have changed it into linear form. Now we need to let minus y minus 1 by y equals to z. Now after differentiating this value, we are getting 1 by y square equals to dz dy. Okay. Now let's convert this value to here. Now let's find the integrating factor with the formula now again we have to substitute x cube equals to t and differentiate. So this is the final answer.